Okay. Hello everyone, my name is Anurag Vempati, and today we're going to be learning about LORAN problems, or long-range navigation problems. And this is for pre-AP, pre-cal at Allen High School. Honestly, probably only people watching the videos will be going there, so I don't know why I'm talking about that. Anyway, so in a LORAN problem, you can assume a few things. The things that you can assume are the problem is going to look a little something like this. So this is just a general sketch of a hyperbola. These are the foci. This is the vertex. These are the vertices, rather. And this is the center, which we can assume is at the origin. So, with a LORAN problem, there is going to be a ship along one of these hyperbolic curves. So, the thing is, with that ship, it transmits to these stations to triangulate its position and relay messages and stuff, whatever, blah, blah, blah. The thing we care about is the fact that it's a math problem. So, with a hyperbola, the distance from the further focus to a point on the opposite curve is d2, and the distance from a point on the corresponding curve is d1. And d2 minus d1 is equal to 2a. So the point of this problem here is we're trying to determine where the ship would reach the shore if it followed the indicated hyperbolic path, which is this little thing right here. So we're just looking for this vertex. So knowing that d2 minus d1 is equal to 2a, and there's a little bit of physics here, knowing that velocity is equal to distance divided by time, the problem gives us a few variables for us to fill in. So to figure out how to do this problem, it gives us a few variables. V, or the velocity of light, which is what travels along these lines, is 186,000 miles per second. And the time it takes for all this to happen is 0.00595 seconds. So what we can do with this information is, because we're trying to find what d equals, we can modify this equation. So if we multiply both sides by time, time cancels here, and here, velocity times time is equal to distance. So 186,000 times 0.00595 is equal to our distance. So when we do that, we get 186,000 times 0.00595 110.76 is equal to d2 minus d1, which is also equal to 2a. So we know that this is equal to 2a. Well, why are we finding a? A is the distance from the center of the parabola to a vertex. So this is a. This is also a. So, because 110.67 is equal to 2a, a is equal to 55.335. So this is our answer for part A, because A was asking if the ship were to follow the path, where would the ship reach the shore? At the vertex. So the point, if this is 0, 0, the center is 0, 0, is 55.335, 0. And for part B, it's asking for the distance to the nearest Lorentz transmitting station. So the transmitting stations themselves are the foci, and these are the hyperbolic curves. If you're wondering why, that's just the nature of the Lorentz problems. This is how they work. These problems here. That's how they work. So if we're looking for the distance from the ship to the transmitter, we know the distance from the center to the ship, we need the distance from the center to the transmitter. Well, in the problem, they also tell us that the stations, or the foci, whatever you want to call it, are 342 miles apart. Which means that this distance here, from this foci to this foci, is 342. So if we want to find the distance from the center to this foci, it should be over here. Ignore that. It's over here. If we want to find the distance from the center to the foci, if this is equal to 2c, this is c. So 342 is equal to 2c. C is 171. So to get this distance right here, all we have to do is c minus a, because this big distance minus this distance gets us this little difference in here. And as you're about to see, the diagram is terribly drawn not to scale. C minus A, so C is 171, and A is 55.335. That will get us 115.665. Oh, whoops. Right, so it's actually a lot bigger than that distance. That's drawn on scale, but whatever. So this is how far it's going to be away. 115.665 miles. And that is your answer for part B. So to recap, the answer for part A is 55.335, and the answer for part B is 115.665 miles. 0. Okay, and this is problem 3 on the back of worksheet. Worksheet 7.3 homework. And that is how you do that problem. If you have any questions, let me know in the comments below.